Welcome to the Explainer. Today, we're going to break down the MCP architecture. It's a design that answers a really critical question. How do you let AI use powerful tools without, creating a total security nightmare? Let's get into it. Okay, so let's just start with the core challenge that pretty much everyone building with AI is facing right now. We've got these amazing, powerful large language models, and we want them to do real stuff in the world. We want them to use tools like GitHub or Slack, or maybe our own internal databases. But how do you actually do that without just plastering API keys everywhere, or worse, getting completely locked into one company's specific way of doing things? And that right there, that's the fundamental problem that the Model Context Protocol, or MCP, is built to solve. It's all about creating a standard, a common language, so all these different pieces can talk to each other safely and, without all the usual chaos. The answer MCP gives us isn't some kind of magic bullet. It's actually a really, really clever architectural pattern. It's all about separating the jobs into three totally distinct roles. This makes sure that every single piece of the puzzle only knows what it absolutely has to know to do its job, and nothing more. So let's meet the cast of characters in this whole ecosystem, because once you understand what each one of these does, the elegance of the whole system just kind of clicks. We've got the client, the server, and of course, the model. All right, first up is the MCP client. Now, you should think of this as the project manager, the central hub, the orchestrator of the whole show. This could be a desktop app that you use, or it could be your own custom application that you're building. Its main job is to talk to all the different servers, figure out what tools they have, and then play traffic cop, routing messages between the model and whichever server needs to handle it. Next, we have the MCP server. This is the bouncer, the secure gatekeeper. Each server is basically a specialized armored box built around one external service. So you might have one MCP server for your GitHub tools, a totally separate one for Slack, and another one for your private database. The server's only job is to hold the secret keys and do the work securely. And finally, the star of the show, the model, the LLM. This is the brains of the operation. It's absolutely brilliant at understanding what a user wants and then figuring out, okay, I need to use this tool, and here's the information to give it. But, and this is the most crucial part, the model is completely blind to how the tool actually works or what credentials it needs. It's totally isolated from all that messy, sensitive stuff. So we've got our three players, the client running the show, the server guarding the secrets, and the model doing all the thinking. The big question is, how do they actually talk to each other to get things done without stepping on each other's toes? Well, they communicate using a really well-established standard. It's called JSON RPC 2.0. And the huge benefit here is structure. Every single message has to follow a strict, predictable format. It means every request and every response is crystal clear, it has a version, and it's super easy to log for debugging. There's just no guesswork. Before any real work gets done, the client and server do this little dance. It's called the initialization handshake. The client basically connects and says, "Hey, I'm here. This is the protocol version I speak." And the server replies, "Awesome, great to meet you. Here's a full menu of all the tools I have on offer." This discovery part is so important because it means the client can work with any server, even when it's never seen before. Okay, let's make this real. Imagine a user types create a GitHub issue. The client gets that, knows it can't do it alone, so it passes it to the brains, the model. The model thinks for a second and says, "Aha, I need the create issue tool, and here's the title and body for it." The client then packages that up into a nice structured message and sends it to the GitHub server. Then the server, and only the server, uses its secret GitHub token, makes the API call, and sends back the result, like the URL of the new issue. Simple, clean, and totally secure. So we know what they're saying to each other, but how are those messages actually getting from point A to point B? Because that choice is a really big deal for both security and flexibility. One of the coolest things about this protocol is that it's not picky about how the messages travel. For a local desktop app, the easiest way is something called Studio, where the server's just another process running on your machine. Super simple. But if your server lives out on the cloud, you can use something called server-sent events, or SSE, which just works over the normal web. This flexibility means you can use MCP in pretty much any environment you can think of. And this whole idea of separation leads right to these amazing security benefits that are just baked into the architecture. Number one, your credentials, your API keys, they live in one place and one place only, the MCP server. Number two, you can set really clear permission boundaries for every single tool. And three, because every message is structured, you get a perfect audit trail of everything that happens, basically for free. So look, if you remember one thing, one single thing about MCP security from this whole explainer, please make it this. The model never sees credentials, period. It doesn't even know they exist. It just knows about an abstract tool, and that is a massive security win. All right, let's zoom out a bit. What does all this actually mean for you as someone building AI tools? Why should you really care about this specific design? Let's talk about why this architecture just flat out wins. I mean, when you stack MCP up against the other ways people try to do this, it's not even a contest. You could just call APIs directly in your app, but that's fragile and your secrets get mixed in with your logic. It's a mess. You could use a function calling feature from a big AI provider, but then you are completely locked into their ecosystem. MCP, though, it gives you amazing portability, a security model that's crystal clear, and you can compose systems by connecting one client to tons of different servers. It's just better. So really, it boils down to four huge wins for you as a builder. It's modular, so you can swap out a server or a client like they're Lego bricks. The security isn't an afterthought. It is baked into the very design. Debugging is way easier because you can actually read the messages going back and forth. And it's extensible, meaning you can keep adding new tools and capabilities without breaking everything you've already built. So the MCP architecture gives us this really elegant, really secure foundation for all the parts to communicate. But that framework is only half the story. And that leaves us with one final, really important question to chew on. Now that the plumbing is secure, how do we make sure that the actual tools themselves, the contracts we define for them, are built to last? How do we future-proof them? Well, that's a story for our next explainer.